So hi again. So in this video, this is going to be like a last video for the numbers chapter from ML Agarwal Applied Math. So the last topic under numbers is basically binary division. So given two binary numbers, how do we divide from one from the other? So unlike just like the other topics, the approach is like again super straightforward, nothing to break your head or any of it. And yet again, we're not looking into super complex numbers like point values like 110.1, meaning let me just explain this with an example. So when you divide 7 by 2, right, so we're going to have 3 6 and then we have a remainder of 1. So most of the cases we don't stop there, we want to divide the 1 as well completely. So we just add a 0, which makes us to add a point value, and then we say 2 5s are 10 and then subtract and we get a 0. Now I'm not considering any of the point values, that is not my scope of interest. So we're not considering any float values in our number, so these values are called as float, right? So just like how I'm not considered or interested about 3.5, I'm also not interested about point values in the binary part as well. All right, so when I'm dividing these two numbers, I'm just considering about a quotient, like an integer quotient and an integer remainder, no point values whatsoever. Got it? So let me just see. So we have the values as of now over here. 2 divided by 7 is basically we get a remainder of 1. Alright, let's just see if that is the case. So 7 could be represented, 7 in the decimal could be represented as 111 in binary, and 2 in decimal could be represented as 10 in binary. Alright, so let us just divide 111 by 10. Alright, so 10 if I multiply with 1. So again, like when you're multiplying these values, right, the quotient or the remainder are all possible combinations of ones and zeros. So either this number I multiply with 1 or either this number I multiply with 0. So these are the two different possible cases with which you will be multiplying. So even the multiplication is going to be like uh, easy, like easy peasy work. Okay, so 10 I'm multiplying with 1, so I'm getting I cannot multiply with 0, I can only multiply with 1. So keeping it there, multiplying with 1, so we have 10, subtracting it, so 1 minus 0 is going to be 1, 1 minus 1 is going to be 0. Now I have a 1 left over, I get this down again, and then multiplying 10 with 1 because I can still subtract. Subtracting this, I have 1 as a remainder, and that's it. So we have the quotient. So if you convert this particular value into decimal, this is going to be 1 plus 2, which is basically 3, and the binary conversion of 1 is yet again going to be 1 in decimal. Alright, so we got 3 over here as suggested, and we also got 1 as a remainder over here. Alright, same. Now in our next case, which we have 5 by 33, so 5 by 33, it's going to be 5 6 are 30, and then we have a 3 as a remainder. Got it? So we'll see how this works out. So 33 could be represented as, in binary, it's going to be 2 1, and then we have 13, 2 6 are 12, and then we have 1, 8 2 8, and a 0, 2 4, and then a 0, 2 2, and then 0 2 1, and a 0. Okay, so it's going to be 1 4 zeros followed by another 1. So we have 1 4 zeros followed by a 1. So 2 4 8 16 32. So yeah, got it. And then 5 could be represented as so let me just divide 5 by 2. So 2 2s are 4, and then I have a remainder 1 1 0. Got it. So it's 5 could be represented as 1 0 1. Alright. Okay, so yet again I can only multiply this with either 0 or 1. So the first 3 digits of this entire number is 100, which is basically lesser than 101. So I'm not going to consider 3 numbers at once, I'm going to consider 4 numbers at once and then start dividing those 4 numbers. So I can only multiply this number with either 1 or 0, right? So 101 I'm multiplying with 1, and then I'm taking 4 numbers at once and then subtracting. So 101. So I'm subtracting this with 101. So I'm having 0 minus 1, obviously 1 is greater, right? So I'm going to borrow it from the most recent value. So borrowing it, this becomes 10, again borrow, 1 0, again borrow, again 1 0. So 1 0 minus 1 is going to be 1, and then we have 1 minus 0 is going to be 1, then we have 1 minus 1 which is going to be 0, 0 minus 0 is going to be 0. Right? So the next number that we have is going to be 0 that we're going to carry over, like bring it down. So now we are again multiplying 1 with 101, so 101 I'm multiplying again. So again carry over, borrowing those values again. So we have 1 0 minus 1 which is 1, 0 minus 0 is going to be 0, and then we have 1 minus 1 as 0. Okay, the last but not the least we have a 1. Okay, now I got 1 down, but I'm not doing anything, so I have to add an extra 0. It's something like, let's say you're multiplying 3, dividing 30 by 3, right? So I multiply this 1, I get 3, and then it's a 0, but then there's a 0 left over, so I bring it down. Just because I bring this down separately, I'm not done anything, I add a 0 over here extra, right? Similarly, I got this 1 down, but I've not done anything, so I'm pretty much unused, so I add a 0 towards the end, just like how you do with 30 divided by 3, adding this extra 0. Similarly, you add this extra 0. Got it? So now this number is basically 2 plus 4, which is 6, and this number is basically 1 plus 2, which is 3. So we got the same values. So the quotient as 6 and the remainder as 3. Alright, same. So the next number that we have is 109 divided by 7. So 7 1 we have 7, minus we have 3, and then 39. 5 are 35, and then we should get 4 as a remainder. So the quotient should be 15 and the remainder is going to be 4. So 7 is yet again represented using 111. 109 alone, let me just divide and find it out. So 2, 5s are 10, 4s are 8, and then we have a remainder 27, 0, and then 2, 2, 3 is 6, 13, 26, and then remainder 1, 2, 6, remainder 1, 2, 3, remainder 0, 2, 1, and 1. So the equivalent conversion that we had over here was 1, 1, 0, 1, 1, 0, 1, 1, 0, 1. Got it? I think I made a mistake by chance. Let me see. So I have 1 plus 4 plus 8 plus 16, 32, 64. So I'm getting 5, 13, 13 plus 32, and 64 is going to be 7, and then 9. Yes, I'm getting the same value. So 6, 9, and plus 1 is going to be 10. Yeah, getting the same value. No issues. Alright, so let me just continue the division. So yet again, I cannot directly use the first 3 numbers because 111 is obviously greater than 110. So taking 4 numbers at once, multiplying this with 1, so I have 111. Got it? So 1 minus 1 is going to be 0, and then I cannot subtract 1 from 0, so borrowing it over. So 1 0 minus 1 is going to be 1, and then yet again I'm borrowing it over, so 1 0 minus 1 is going to be 1. Alright, can I divide 111 by 110? No, so I have to get another value down. So again multiplying this with 1, so 1 1 1. 1 minus 1 is going to be 0, again carry over. So 1 0 minus 1 is going to be 1, this is 0 again, right? So again carrying over this with this value, so it's going to be 1 0 minus 1, which is going to be 0, and then I have 0 minus 0 0. Now the next value I'm going to bring down is 0 again, so 1 1 1. Now I have to carry over, so 1 0 and then 1. 1 0 1. Alright, so the last number that I have to bring down is 1, again multiplying with this 1, so I have 1 1 1. So I'm gonna get 0 0 0 1 1 0. Alright, so what do we have here? Is there anything else that I could divide further with? No. So we have the remainder as 4. So this is 0 into 2 power 0, 0 into 2 power 1. So directly 1 into 2 power 2, which is basically 4. Equivalent is 4. We got 4. And let's see the numerator. Sorry, I mean the quotient. This is going to be 2 power 0, 2 power 1, 2 power 2, and then 2 power 3. Right, so 8. So we have 1 plus 2, right, plus a 4 and a plus 8. So 12 plus 2, 14, 14 plus 1, which is basically 15. So we got 15. Alright, so I think this is like binary division made easy according to me. So hope you guys have also understood. So if in case you guys have any doubts at all, please don't hesitate to call me. I'll be happy to help you out anytime. Alright then, thank you. See you guys in the next video. Bye.